Hello guys, welcome back to channel. Today in this video we will learn how to identify carboxylic acid group that present in an unknown organic sample. Okay, so let's start our discussion. Basically, there are two type of tests by which we can determine carboxylic acid group in an unknown organic sample. Okay, one is bicarbonate test and another one is esterification test. So let's start with bicarbonate test. Here a pinch of solid sodium bicarbonate, that is NaHCO3, is added to an alcoholic solution of the sample. If we get effervescence of CO2, therefore this effervescence of CO2 indicates the presence of carboxylic acid group. Okay, let's see the reaction during this bicarbonate test. Okay, here this is my sample. I do not know whether in this sample carboxylic acid is present or not. If carboxylic acid is present, then this carboxylic acid react with sodium bicarbonate to form carbonic acid and C double bonded O single bond O Na. And this carbonic acid will break down into water and CO2. Okay. On the other hand, in case of esterification test, 0.5 gram of sample is taken in a dry test tube with 5 ml of methyl alcohol. Here we use methyl alcohol instead of ethyl alcohol. And 2 drops of concentrated H2SO4. This reaction mixture is warmed in water bath. Keep in mind, warmed in water bath for few minutes. Then this solution is cooled and poured into aqueous sodium carbonate solution, Na2CO3, is taken in a beaker. If we get sweet smell of ester, then it confirms the presence of carboxylic acid. Okay. Now let's talk about reaction during the esterification process. This is sample. In that case also, I do not know whether carboxylic acid group is present or not. If carboxylic acid is present, then this carboxylic acid will react with methanol. In presence of acid, we will get ester. Here C double bonded O-Me and water. Okay, this is the bicarbonate test and esterification test. Okay, now keep in mind some point regarding this test. Okay, so number one, other than carboxylic acids, there are some stronger acidic substances like nitrophenol, aniline hydrochloride, vanillin, sulfanilic acid give the bicarbonate test. Okay, like nitrophenol. Here nitrophenol, the structure of nitrophenol is structure of aniline hydrochloride is, this is aniline and this is aniline hydrochloride. And here sulfanilic acid, that is NH3 plus SO3 minus. And here vanillin is benzene ring OH OCH3. Okay, Number 2, sodium bicarbonate, that is HCO3 minus, is preferable over sodium carbonate, that is CO3 2 minus, for the detection of acid group. Okay, let's talk about bicarbonate and carbonate. Okay, bicarbonate HCO3 minus and carbonate CO3 2 minus. Okay, this carbonate ion is stable due to resonance hybrid. Therefore, it is highly stable compared to this bicarbonate. Here, this is comparatively less stable than carbonate. Comparatively less stable than CO3 2 minus. Therefore, it is less. Therefore, as carbonate is highly stable, therefore it is less reactive. Less reactive. On the other hand, bicarbonate is comparatively more reactive. More reactive. Therefore, if I try to make carbonic acid from this bicarbonate ion, one proton is required. On the other hand, if I try to make carbonic acid from carbonate ion, two proton is required. Therefore, activation energy of carbonate ion to form bicarbonate is higher. Activation energy is higher. On the other hand, here activation energy for bicarbonate ion to form carbonic acid is lower. That's why we use sodium bicarbonate over sodium carbonate for the detection of acid group. Okay. Now, if the sample only give the effervescence test, then esterification test is to be performed. What is esterification test? Esterification test is nothing but, this is my sample. I do not know whether carboxylic acid group is present or not. If carboxylic acid group is present, then this carboxylic acid group will react with methanol. In presence of acid, we will get ester. It has sweet smell. Okay, this ester is C double bonded O O M E. Okay, now esterification test depends on the volatility of the formed ester. Okay, here in esterification test we use methanol and we do not use ethanol. The reason behind it, methanol is more volatile, and number 2, ethanol itself has a sweet smell. Okay, now if the compound gives the positive bicarbonate test but not give esterification test, there are certain compounds which gives positive bicarbonate test but not give esterification test. Okay, so basically it has two possible reasons. One is the possible reason behind this ester may be less volatile. At the formed ester may be less volatile. Less volatile. Ester may be less volatile. On the other hand, the compound does not contain carboxylic group. The compound does not contain carboxylic acid. There are some compounds which do not contain carboxylic acid group, yet they are positive for bicarbonate test, like nitrophenol, aniline hydrochloride, vanillin, sulfanilic acid. Okay, and there are certain substances which ester are less volatile, like nitrobenzoic acid, parahydroxy benzoic acid, etc. Okay, now an amide may respond to the esterification. Yes, this is quite interesting. An amide may respond to the esterification test. Okay, and that type of amide is salicyl amide. Okay, and its structure is this is salicyl amide, and in presence of reaction condition, in this reaction condition of esterification, it transform into oil of wintergreen. Oil of wintergreen. Pause the video and write down in comment section what is oil of wintergreen. Okay, oil of wintergreen is nothing but methyl salicylate, that is an ester. Methyl salicylate, that is this is methyl salicylate. This is known as oil of wintergreen. Thanks for watching this video.